In this lesson, we will have discussion on another sequence known as tuple. Just like a list, tuple also is an ordered collection of objects. I have seen people using tuples less often, mainly because these look very similar to the list. It's true that there are many things common between a list and a tuple, but there are many things which are different in tuple from the list. So in this video, we will see the detail of tuples and will use them in a few tasks. A tuple is defined by placing the different objects inside the parentheses rather than the square brackets as in list. So this A is a tuple having 3 elements or objects 1, 2 and 3. Let's print the type of A and also the value of A. So A is an object of tuple class and this is how A is displayed, showing the 3 objects stored inside it. Now we will discuss the things common in list and tuple. For that I will place 2 files side by side. The left file contains some operations on a list and the right file has the same operations on tuple. Here on left side we have a list with few elements and list is printed. And here we have a tuple with the same elements as of the list on the left side. In case of list, we know the elements inside the list can be accessed using the index. For example, A3 will be the 4th element of the list, A-1 is the last element, and this A1:4 is a list slice of elements on index 1 to 3. List slice returns a slice in the form of a list. Now in case of tuple, we can also access the elements using the index. Please note that we have to use the same square brackets to specify the index. Index 3 means the 4th element and -1 index refers to the last element of the tuple. And again we can have a tuple slice. For example, 1:4 will slice from index 1 to 3. Note that tuple slice will return a tuple. We can use in operator to check the membership of an element inside a list. 3 is inside the list, so it should return true. Exactly like that, we can use the in operator for membership test inside a tuple. List is iterable, meaning that we can apply the for loop directly on the list. And tuple is also iterable, allowing the for loop directly on it. There are two ways to create an empty list, either by using the empty square brackets or by using the list constructor. Likewise, we can create the empty tuple in two ways, either by using the empty parentheses or by using the tuple constructor. We have a few list operations like the plus operator between two lists will concatenate the two, and the asterisk operation with an integer will repeat the list element that many times. Let's see the same operations on tuples. Sorry, this B should be a tuple here. We are applying the same plus operator and the asterisk operator. And we have the exact same functionality in the form of tuple as well. Let's see if we can concatenate a tuple with a list. And that is not possible. Now on list we can have the comparison operators. We have the exact same case for the tuple as well. Then we have some built-in Python functions for lists. For example, length returns the total number of elements in the list, max and min returns the maximum and the minimum value inside the list, while sum returns the sum of values inside the list. And again we can apply the same built-in functions on a tuple object as well with exactly same results. Then we have the built-in functions all and any, which can be applied on the list. All returns true if all elements inside the list are true, or in other words, no value is 0 or false. The function any returns true if there is at least one true value inside the list. I will add a 0 in B, so all should return false and any should return true. Let's test the two functions on tuple now. And we have the same behavior. Now we have this built-in function sorted, which when applied on a list will return a sorted list without changing the original list. When we apply this function on a tuple, it will return a sorted list. See carefully, it returns a sorted list and not a sorted tuple. So there are so many things common in list and tuple, but even with these common things between the two, there are some performance measures by which we can compare the two. Two very important performance indicators are the memory consumed by an object and the time execution to create one object. I am defining a list with different values. Now I have a tuple with exact same values. We can find the size of an object in bytes by using a function getSizeOf, which is available in the sys module. Let's display the size of the list and the tuple. And see that the list is of 120 bytes while the tuple is of 80 bytes. That's a big difference. When we deal with larger datasets, for example in the field of data science and big data, there can be datasets with millions or trillions entries, and imagine how big will be the memory size difference then. Now let's compare the time execution of creating a list and creating a tuple. For that we can use the function timeIt available in the module timeIt. To use this function, we have to provide the statement we want to execute by using the parameter statement stmt. So first I will create a simple list with the values 1, 2, 3, 4 and 5. The time execution for one small list is very short and might not be compared well, so we can also provide the number of times we will execute the statement. So I will execute the statement for 100 million times, meaning that the list A is created for 100 million times. This function will return the time taken for this. Now let's create the exact same tuple with again 100 million times. Let's print the two times. I will fast forward the video till we get the output. So the list took 8.8 seconds while the tuples took 2.568 seconds. Again this difference is big. So the tuples take less memory and also the less time. So does that mean tuples should always be preferred? This good performance of tuples comes with a price. Let's see the methods or the functions available inside the list class and the tuple class. The starting methods rounded between the double underscores are special methods also known as magic methods and are used for different built-in operations which we cannot discuss here. So just ignore those, and we have 11 other list methods which we can apply on the list object for different logic. While in case of tuple we have only two methods in the tuple class, count returning the count of specific element inside the tuple and index returning the index of an element provided as the input argument. So we don't have a variety of methods in the tuple class. Now let's see another very important difference. I have this list A. If I want, I can update the first element of the list from 1 to 10 like this. And the element is updated. I will change this list to a tuple. And in this case we have an error that tuple object does not support item assignment. Once a tuple is defined, we cannot change that and we cannot add any new element inside the tuple. We call that a tuple is immutable, meaning once it is created, we cannot change it. On the other hand, list is mutable, meaning we can change it after it is created. There is a lot more on mutability or immutability of a data type, and we will have a detailed video on that. We know a tuple is defined by placing the elements inside the parentheses as shown here, but we can also omit these parentheses. And still it is a tuple. Let's check that. It is printed as a tuple and it is an object of tuple class. This is basically known as packing of elements into a tuple. The elements 1, 2 and 3 are packed to form a tuple. Let's discuss a bit more on packing and unpacking of tuples. Here A on line number 2 is a tuple having 3 elements. I can have this type of assignment, assigning the tuple to 3 variables. It will unpack the tuple and will assign the first value to x, second to y and third to z. Let's verify by printing the value of x, y and z. And you can see those. When we unpack a tuple like this, it is important to assign that to the number of variables equal to the elements of the tuple. For example, the tuple has 3 elements, and if I try this to unpack to 2 variables, that will generate an error. And if I just have one variable on the left side, it actually is not unpacking, we are just creating a copy of tuple A. So x will also be a tuple. But there is one more possibility. For that, I will add more elements inside the tuple. There are 10 values inside the tuple, so if I unpack the tuple as so, we know it will generate the error since we have specified 4 variables for unpacking the tuple and tuple has 10 elements. But if I put an asterisk sign before this last variable p, now there won't be any error. What this asterisk means is that all remaining elements will be stored inside the variable p as a list. Let's print all 4 variables. So these are the values of the first 3 variables as first 3 elements of the tuple, and the remaining 7 elements of the tuple are stored in the list P. I can also put the asterisk on some other variable and not just the last variable. In this case, tuple will get unpacked and first 2 values will be assigned to m and n, the last value will be assigned to p, and the remaining will be assigned to o as a list. You can see that here. Of course, I cannot place asterisk with 2 variables since Python cannot decide how many values to assign to which of the 2, so we get this error. Just for one last time, I will place the asterisk with the first variable, and I hope now you can guess that the last 3 values will be assigned to n, o and p, and the remaining starting values will be saved in m as a list. Now let me show you an interesting thing. If I have a equal to 5, of course it means a is of integer data type and the value is 5. Instead of assigning 5 directly to variable a, we can introduce a middle variable like assigning the 5 to a variable, for example x, and then assigning that x to variable a, and hence a will get the value 5. Now I will do the same for the multiple assignment statement. You know, we can have multiple assignment or parallel assignment, assigning values to more than one variables. Now if I introduce a middle variable here, just as we did earlier, I am assigning the values to x first, and then that x is assigned to a, b and c. So here what do you think this x is? The values 1, 2 and 3 are packed together and assigned to x, making the x a tuple. And then over here that tuple x is unpacked and the 3 values are assigned to variable a, b and c. So there is packing and then unpacking of the tuple. We don't see this packing to tuple and unpacking of the tuple when we use the parallel assignment, but internally it is handled like this. And that is why it is so simple to swap 2 variable values with each other. So here first these values are packed and then unpacked to these variables. If I have this statement, it is same as this statement, or it is also same as this one, or even this one. These 4 statements are one and same thing, assigning 2 to x and 3 to y. Now I am defining a simple test function with 2 input arguments a and b. I want to return their sum and difference. I can return the 2 values. We say that function is returning 2 values. It is totally fine to say like that, but in fact the function is returning one value. The variables x and y are packed together to form a tuple, and that one tuple is returned. Let me show you that in the main program. We use this function by assigning it to two variables, for example m and n. M is having the sum and n is having the difference. What if I assign the function output to a single variable? Will that be sum or the difference? Let's print that and also the data type. So you can see m contains both values as a tuple. It means that when we use this function like this, the function is returning a tuple here with two values inside it, but we know when a tuple with two values is assigned to two variables, that gets unpacked and its two elements are assigned to the two variables. Now m is the first value of the tuple, which is an integer. Now here I am copying a code where I have created a few tuples with different number of elements. For example, this t1 is an empty tuple. I am printing the tuple and the data type of t1. Then is t2 with one element and it is also printed. Then t3 has two elements and t4 has three elements. Let's run it. You can see t1 is empty tuple, t3 and t4 are also tuples, but if you see this t2 having one element, it is printed as integer object instead of tuple. Let's see why is that so. Here we have defined the tuple with one element just like any other tuple, but if you see this one written inside the parentheses, we can use the parentheses for any mathematical expression. For example, 1 into 100. Now how does Python decide if we want this one to be a tuple or simply integer? And Python treats it like any other expression written inside the parentheses. So this is treated as integer. However, if we need to have a tuple with one element, we need to put a comma sign after that one element. Now it is clear that this is a tuple with just one element. You can see this is printed as tuple now. Of course, we can just omit these parentheses and still these will be tuples. But we cannot remove the parentheses for this empty tuple. Now before moving to some tasks using the tuples, I will discuss one last thing. We know list and tuples are sequences and there is a way we can convert one to other using the respective constructor. So I am defining a tuple here. If I want to have a list with the same elements, I can convert this tuple to list using the list constructor. Let's print both A and B. And you can see A is tuple and B is list. Likewise, if A is a list and I want to create a same tuple, I can convert that to tuple using the tuple constructor. You can see A is list and B is tuple. So if I have a tuple and I want to sort that, let's try to do it, but we don't have the sort method in the tuple class because tuples are immutable and once created we cannot change those. But we have the built-in Python function sorted which we can use and this function will return a sorted list. So B is a sorted list and it has not changed the tuple A. If I am interested to get a sorted tuple, I can use the tuple constructor on the result of sorted function. You can verify it has not changed the tuple A. Now we will move to some tasks using the tuples. Here is the program to find the zodiac sign from the input month and day. We did this task in the last lesson using the nested list, so I will not discuss that in detail here, but just see that it is now nested tuple here having the inner tuples. This is the inner tuple for January, this is for December, and this is the last tuple with single value. Again, I will say if you need the detail of this program logic, you should see that from the last lesson. Over there we use the nested list and here we are using the nested tuple. This just illustrates that we can use a tuple instead of list, getting the advantage of less memory and less execution time. Now let's see some new cases. Suppose I want to store the information of some element of the periodic table. Suppose the properties I want to store are name of the element, its symbol, atomic number and atomic mass. Now these properties of periodic table elements will not change, so it's better to use a tuple for that. I will copy a few elements created as tuple from another file. This element 1 is for hydrogen, the name is hydrogen, symbol is H, and atomic number and atomic mass is 1. And we have 3 more such elements. You can create all periodic table elements like this. Then if I need the complete periodic table, I can create a list of these elements. So this is a list of tuples. I made it a list so that we could apply different list operations on it, like adding more elements, etc. For complete periodic table, we could also have a 2D list just like the actual periodic table, and row and the column will specify the periodic number and the group number of the elements as well. I'll keep it like this. Now let's do some queries on this table. Suppose I want to display just the symbols of the elements having the atomic mass between 4 and 8. So I can apply the for loop on the periodic table, which is a list. This variable element is the object of the list, which is a tuple, and the information of atomic mass is the last element inside those tuples. Since variable element is tuple, so I can unpack its elements as so. So the 4 values inside the tuple will be assigned to these 4 variables. I will apply the condition if atomic mass is between 4 and 8, I need to display the symbol, and that is in the variable symbol when we unpack the tuple, so I can use that over here. So helium and lithium are the 2 elements with atomic mass in range 4 to 8. We know this variable element is a tuple and that is being unpacked in the next line, but I can unpack that tuple right over here. And now I don't need this. You can say this for loop has 4 loop variables, each getting the value from the tuple inside the list periodic table in each iteration. Again, here I cannot unpack just the first 3 values of the tuple. Now let's see another case. I hope you know the colors are presented as RGB code, where R is for red, G is for green, and B is for blue. These are 3 primary colors, and we can make any color by mixing these in different ratio. In digital domain, the 3 colors are represented in 8 bits each, so in decimal each of the color can have a value from 0 to 255. In some application, I might need to set some colors, and for that I can use the tuple. These are the 3 values of R, G and B. I will copy a code from another file. So you can say I need to have 4 colors in my application. So these are the 4 colors and I have put those inside the list, so that if later I need another color, I can add that into the list. So again we have a list of tuples, and that's something very common. Lists without a doubt are most widely used data structure because of the support of variety of list operations, and we see many times a list having the elements of other sequences or collections. Now let's say I want the colors having the different values of R, G and B codes, so I can use a for loop on the list, and again I can unpack the tuple inside that list. So these R, G and B are the 3 values inside the tuple. I can apply the condition that all 3 values are different. Then I have to print the color as a tuple. Now I have the values of R, G and B as unpacked but not as a tuple. So I can just pack those to create a tuple. And these are the colors with different values of R, G and B. Now here if I will remove one set of parentheses, now these R, G and B are individual values and not the tuple, because those parentheses are for the print function and not to create a tuple. Now the last task I will do is the information of student to be stored. I want to store the first name, the last name, the registration number, and the courses he or she has registered. I will do it as a tuple. I will explain why in a while. For example, Ahmad is the first name, Anwar is the last name, this is the registration number, and now I need the information of courses registered. That can be one course or the multiple courses, so I will specify that as a list of course names. So here a tuple has an inner list. Now the important thing is why I chose a tuple for the student and an inner list for the courses registered. A tuple is chosen for the student because the student's information is not needed to get updated like the first name, last name or the registration number. But the courses registered by a student might need to get updated, so those are placed inside a list. Now that's something very interesting to discuss, so pay attention here. A tuple is immutable and once created we cannot change it. On the other hand, a list is mutable and we can modify that once created. Over here we have a scenario where a list is one element of a tuple. If you see the other elements of this tuple which are strings, and string is also immutable, so if I will try to change the first name or the last name or the registration number, I will not be able to do that. But this list is mutable, so I can actually change this list although it is an element inside the tuple. I know this might sound a bit strange, but as I said earlier, we will have a detailed lesson on mutability and immutability of data types. Over here, you just need to know that tuple is immutable, but a list is mutable, and if that list is even inside a tuple, we can update its elements. For example, I can access that subject list at index 3 inside the tuple, and now I can apply the list method .append, and let's add another subject physics in this list. Let's print the subject list. And you can see physics is added inside the registered subject list, and that's why we used a list for the subjects. Now I will create a few more students. Total we have 4 students now, and let's create a list to store all those students. This S1 is this tuple and so on. We have so many nested items now, and let's say I want to access the subject list of first student from the all student list. I can do it like list name and index of the first student, which is 0, and that is a tuple. Inside that tuple, the subject list is at index number 3. So to access the subject list of the first student, I will specify the index as 3. Now suppose that from the list I just want to access the first subject CP, and CP is at index number 0 inside that list, so I will specify that as 0 index here. So this refers to this CP. Let's print that. And we got error because I just misspelled the one student variable name. And here we get that CP. So in one way it was good to see triple indices case, and now let's do a query on this data. I want to generate a list of registration numbers of those students who have registered in subject CP. So let's start with the empty list. Now I will iterate over the all student list, and I will unpack the list elements which are tuples. So F is for full name, L is for last name, R for registration number, and S for the subject list. Inside the loop body, I have to check if the subject list contains the subject CP. Subject list is unpacked to loop variable S, and since that is a list, we can use the in operator to check the membership as CP in S. It will return true if CP is inside the subject list, and if that is the case, I need to pick the registration number of the student, and that is in the loop variable R. So I will simply append that into the list CP students. Let's print the result. And you can verify that student 1 and 3 have CP in their registered courses, and these are their registration number. You can add few more students in the list, and the same program will give the correct output for as many students as are in that list. Now I will give you a review question from this same task. First add few more students. I would suggest at least 10 students in the list. Then your program should generate a list of full names of all students who have registered exactly 3 courses. By full name, I mean for this first name and the last name, the full name is Ahmad Anwar. So that's all from this lesson. Thanks for watching.